sine 2 alpha. Okay. Let's just work on the range for the moment.
Range is always of x, isn't it?
Yeah, so range is when it goes, so let's draw this. So we've got this thing, we'll go boom, okay? That's alpha in this case, our angle, and the range is that when it goes all this one here, isn't it? All the way down here. Remember we've got what on this side? X, and up here we've got Y, don't we? So to find the range, like to show that the range is that, what do we have to do to this equation?
Derive it.
Y equals what?
Y equals 0.
Y equals 0 because it's gone back down to the ground, hasn't it? So to get the full range, we substitute Y equals 0 of this guy, don't we? So let's do that. 0. So what I'll do is I'm going to move, because see that's 0, I'm going to move this guy to the other side, so positive, alright? So I'm going to go x tan alpha is equal to, so I've just moved this guy to the other side and flipped it around.
I love motion.
So the maximum range on level ground was the question. Because I guess you can have a range in Y. It's like how far does it go from Y to, but we're talking about level ground, the question of. So I'm going to put that back into sec squared, so let's go x, and I'm going to go tan equals gx squared sec squared x. So 2v squared. I'm going to get x, I'm going to get 2v squared. That side, and then over here I'm going to get gx squared sec squared alpha over x in what we need to get. So that's sort of at the top, and by moving the x down here I can cancel out one of the x's, can't I? So have I missed something? Tan alpha. Let's go 2v squared equals, and we'll go gx, alright? And then we're going to go 1 over cos squared alpha, but that's all over what? Sine alpha over cos alpha, alright? 2v squared. If you want to do it in one step, you can. Sine alpha cos alpha is equal to gx 1 cos squared alpha. Alright.
Multiply both sides by cos.
If I multiply both sides by cos alpha, what happens to one of these cos alpha?
Is that tan squared or is that tan squared?
That's not tan squared, so that's this guy here. Alright? So, see how that's tan here, just here. Alright? So if I multiply both sides by cos alpha, what happens to one of these cos alphas?
It just becomes cos.
That disappears, and that goes like that. And so what I'm going to do now is I'm going to move this one cos alpha left, and I'm going to move it to this side, and I'm almost left with something in terms of x, aren't I? Right. So, and I'm going to move things around. So I'm going to go gx equals, and it's going to be 2v squared sine alpha cos alpha. And then that means that we're pretty much there. X equals 2v squared over g sine alpha cos alpha.
Is this where you go into our formula sheet? Yeah.
Yeah, so what is, see how there's a 2 and then there's this. What double angle formula is that?
Cos.
You should be very familiar. It will be sine. Remember, cos 2x is the one that gives us all our squared stuff, doesn't it? This one gives us sine and cos. So we're actually at the answer. Therefore, x equals v squared over g sine 2 alpha, using our double angle formula. How do I find the maximum range?
Well, could you sub
So we need to know the maximum value of x.
If it says that there was a perfectly horizontal surface,
Then y is going to equal 0.
wouldn't that?
Okay, I'm gonna like. I've done this question a couple of years already, so it's not immediately obvious, but it'll be very impressive if you figure it out. I'll give you a clue. This thing is times by sine 2 alpha. What is the maximum sine 2 alpha can be? Knowing with your knowledge of trigonometry of the sine wave.
180 degrees. Right.
So-
It can be 2.
Oh, is that like
Well, if it's...
yeah. You mean like up, so you can go up to 2 and then come back down to just.
Does sine 2 alpha get up to 2? 2 sine alpha gets up to 2.
So what? It's 1.
Oh,
It's up to 1.
Huh?
1.
1.
Yeah, so this whole thing, because they're multiplied together, will be at its maximum when this thing equals
1.
its maximum, which is
1.
1. So max range occurs when sine 2 alpha equals 1, doesn't it?
Yep. Then you can literally just replace sine 2 alpha with 1 and then just solve for it. No? Like, don't worry.
And we can actually work this out. So if we substitute, say, a u, that what's inverse sine of 1? Well, when does a sine wave hit 1?
Half 2.
Yeah, which is 90 degrees because we're using 90 degrees. So 2 alpha equals 90 degrees, doesn't it?
So alpha is 45.
Therefore, alpha equals 45 degrees. Hey, isn't that beautiful? Like,
You can say that.
don't you imagine that, like, if you 90, like 45 is sort of like on that angle. If I shoot too low, what will happen? It'll fall before. If I shoot too high, what happens? Gravity starts taking over, and it'll fall down here. But at 45 degrees, it gives us the
Exact.
yeah.
Perfect.
Now we've just used maths to
In
prove
math, yeah.
what we always thought. Didn't you always think that that would be the case? You have to get it sort of in the middle.
Oh my God.
Yeah.
So it makes so much sense now.
In reality, I think it's a little bit more because everything's...
So maximum range occurs when alpha equals 45 degrees.
Resistance.
I like it.
Yeah.
Should be right.
I want to do math with air resistance.
No, it's down.
All right. So we've only got 10
We
minutes
live in
left.
air. It helps us live. We breathe.
Not the point. We could have air that we live and breathe without air resistance.
No. How are you going to do that, Andre?
No, if only we had an alternate reality about this.
I've got one more
What you got, Bustos? What you got?
thing, but we don't have time for it. But can I just explain to it? Because I'm going to get you to do some questions. Now, we're going to try
It's really pink.
do every question in this exercise. And then I'm going to give you a HSC question. Do you know why? Because it occurs every year, our projectile motion question. If we get good at this,
Watch out.
like, there's a lot of places we can trip up, isn't there?
Yeah.
But if we get good at this, like, there's nothing sort of like, oh yeah, that was really crazy what we did. Alright? If we get good at this, we can walk in with confidence and go, yep, there's another 5 or 7 marks in my bag walking into the exam, isn't it? So, but because I'm running out of time, I just have to explain. So part 2 says this. Arrange the equation of the path as a quadratic in tan alpha. Alright, so we've got that from pink over there. Alright, and hence show that with initial given speed v, the variable angle of elevation, so this thing, you know how that can change, alright? Projectile can be fired through the point P, X, Y, so it can be fired through this random point here. P, X, Y.
I'm actually playing Styles music.
Only if, and it says, this thing here,
They're like continuing.
2v squared gy v4 minus g squared x squared. Alright? So we have to prove this. Okay? Now, this is so we have to go that we have to have an angle can only be fired through this point if this is the case that occurs. Alright, where do we get this inequality from, all these things from? I'm just really quickly, because it might sort of like, I said this is a quadratic in terms of x, but it's also a quadratic in terms of what? Tan alpha, alright? For there to be an angle, so think of quadratics. There are sometimes that quadratics gives us two solutions. There are sometimes it gives us one solution. And there are sometimes it gives us no solution. So if this is a quadratic in terms of tan alpha, what does something need to be greater than or equal to 0 for this situation to occur? The discriminant. Yeah. So you're going to have to make this in terms of like, in general form in terms of tan alpha. Now that might blow your brain out, but like just in case you wanted to do that over the weekend.
Over the week.
Yeah. Look at this, and that's where we get the inequality from. Alright, so I want you to do questions 1 and 2 for homework. 3H, questions 1 and 2. Adam, write it down. Exercise 3H, question
I'll
1.
even put it on my hands for you.
Will we continue with this next lesson?
Yeah, if you guys do that, that'll be very impressive.
You're fine.
I'm not.
I'm not that smart, so.
Huh?
Thank you.
It fell over.